Hi, welcome to question 5 of the 2025 Leaving Cert Ordinary Level Paper 1. So we'll get stuck in, and part A here says use algebra to solve the simultaneous equations, and it gives me an equation on top here, 3 times x plus 2 times y equals 11, and then a second equation, x minus 4y is equal to negative 1. Now, if I kind of ignore the bottom equation and just focus on the top, this equation had two unknowns. I can't solve it. You cannot solve an equation of more than one unknown. Now, the second equation also has two unknowns, so I can't solve that. But these two equations have the same two unknowns. This is the same x value whenever we find it. This is the same y value. And we can use a trick called simultaneous equations to be able to solve that. Okay. Now, the elimination method is often used, and that's what we're going to do here. You could use the substitution method. Okay, it just depends on the situation, and it just the preference. Okay. Now, there's my two equations again. Okay. Sorry, I've already said that. We're going to try manipulate these equations by joining them together and then canceling one of the unknowns. Okay. Now, in this situation, I think I'm going to go for the x's here. Okay, I need to change the size of this equation. It'll still be the same thing. It's just bigger. But I also need it to be a different sign. So when I combine them, that the x's change. So I'm going to choose multiplying by negative 3. Now, once I do that, okay, my original equation here is this, my top equation is the same. I haven't done anything to that. But my bottom equation, x times negative 3 is negative 3x. Negative 4y times negative 3 is positive 12. Minus by minus is plus. 4 3s is 12. And then negative 3 by negative 1, or negative 1 by negative 3, is positive 3. So this equation on the bottom is the same. The x and y value are the same. It's just bigger. And now when I combine those terms, okay, the 3x minus 3x cancels. There's no x's left. And I have the 12y plus the 2y is 14y, and the 11 plus the 3 is 14. Now you probably could guess this. 14 times some number gives 14. The number has to be 1. But if you want to use algebra, if I divide the 14 by 14, and divide by itself, I turn into 1. I'm allowed to do that as long as I do the same thing to everything on the far side. And in that case, is 14 divided by 14 is 1. So now I know my y value. And the trick is to find the x value. I use either of my other equations. Now I'm going to go with the top one just because I don't make negatives necessarily or something. It doesn't really matter. And I'm going to substitute the one that I now know from what I just did. So this equation of two unknowns is no longer two unknowns because I know what y is. I can swap it in brackets and then manipulate it. Okay, 2 times 1 is 2. To get rid of that 2, I'm going to take 2 away from it. If I do it to one side, I have to do the same thing to the other. I've created a little sum here. 2 minus 2 is 0. So that's gone, which is what I wanted to do. On the far side, 11 take away 2 is 9. So 3 times some number gives 9. It's 3. Now, I could divide by 3 on both sides to do that algebraically. But if you know what you're doing and you know what the answer is, just go straight for it. Now, that's part A. Now, part B says solve the following equation in x is an element of R. And again, that just means that x can be any number. And we have a quadratic, okay, 3x squared minus 2x minus 4 is equal to 0. Now, quadratic is a very specific kind of pattern that we see all the time in the world. And I've always struggled to explain why, but not that long ago, it was kind of pointed out to me that that's what gravity is. And if you throw a ball in the air, it'll follow a quadratic pattern to come back down to the earth. So why do we need to understand quadratics? Because everything in our world is controlled by gravity. So if we can understand that, that's a great way to understand our world. Now it says give each answer correct to 2 decimal places. Now I appreciate I've been doing this for years, so the second I see that I go, it's quadratic, and I know what my strategy is. If you see a quadratic, that means it's got a power of 2 is the biggest power. Okay, it doesn't have to have anything else. It just has to have an x squared. Then it's quadratic, and the most basic quadratic is x squared equals 0. Okay, then I know that I can solve it, and that generally is the strategy. Okay, is solve the quadratic, and There's a fast way of doing it that doesn't always work, but the quadratic formula always does work. Okay. Now the quadratic formula needs to know like three things for it. Okay. It needs to know what the a value is. Now I've written the quadratic out. I've written the general form of a quadratic, which is given to you in the maths tables with the quadratic formula. And when I write them on top of each other, it's maybe more obvious, and I've tried to use color things. A is equal to 3. B is equal to -2. It's the whole number here. C is equal to -4. Okay, and that's what's in the quadratic formula jumbled around. So I've identified my three values, and now all I need to do is substitute them in. So the B I identified as -2. I put it in brackets. The B here, I do the same thing, and I make sure to put it in brackets because we're going to heavily use the calculator in a second. The A value was 3. I put in brackets. The C value is -4. And down the bottom here, we can't forget this, the A value again is 3. Now, I generally use the calculator for this, and I put all of this in with just the plus sign, and I press equal, and I get my answer, okay? And then I do the kind of backspace, and I change that positive to a negative, and just press equal again, and I get my answers, okay? You can work it down step by step, and that's fine. There's nothing wrong with that. Just the calculator can be easier, especially if you're able to program it. Right, we'll push on then to C. C says the graph of a quadratic function h of x, so they're using function notation. And essentially, if you want to, for your own sake, just think of this as y. So as x changes, y is changing, and in a quadratic pattern, it's changing in a very specific way. Okay, there can be linear patterns, cubic patterns, trigonometric, loads, exponential, different types of patterns that we've identified in our world, and we use them to make more discoveries and understand our world and our universe better. Okay, so the graph of a quadratic function is shown in the diagram below. It's drawn to scale for some reason. Okay, actually, there's a reason they're saying that. The graph is symmetrical about a vertical line. Now, quadratic functions are always symmetrical. Part 1 says, based on the graph, which of the following pairs of values of x is a possible set of roots of h of x? That is the values of x for which h of x is equal to 0. Now, we'll worry about the numbers here in a second. There's an awful lot of terminology going on there. Okay, so the roots of something are where does that pattern cross the x-axis? Okay, that's all it means. Now that they're being a bit more explicit. They're saying the values of x for which y is 0. Now, if you think about the y-axis, okay, this might be -2, -1, 0, 1, 2, 3, whatever. The place where y is 0 is all along the x-axis. So anything that crosses the x-axis, y is always 0. Similarly, if something is crossing the y-axis, x is 0. Okay, that's a really fundamental thing about graphs that is often assessed. So we're really looking for which of the answers down here could this be? Now we can try exclude. Okay, so I'm just going to use a highlighter or whatever. And I'll try x is equal to 2 and x is equal to 8. Now, both those x values are positive. So it might be here and here. Okay, so it's not that. Okay, so I've excluded this one as an option. Now, if I change the color, okay, then the next one, x is equal to -2 and x is equal to -8. Now, they're both negative, so they'd be over here. So that's not it. I can exclude that. Okay. Now, x is equal to -2, x is equal to +8. Okay. Now, if I think about it a bit differently and compare that to the last answer, this is saying x is equal to -8. Okay. And x is equal to 2. Now, -8 will be off over here, and 2 will be maybe whatever here. Whereas x is equal to -2, I won't bother changing color, might be somewhere there, and x is equal to +8 might be somewhere there. So my answer is this one. Okay, I can figure the answer. So I've said the reason there is they're asking for a reason, I think. The roots of our graph, so are where it crosses the x-axis. The option in this answer makes sense is the roots are negative and positive, which the graph crosses both sides of the y-axis, and the negative root seems to be closer to the origin, and that's why I've chosen that option. Okay, now that's part C. Now, sorry, part C, part 1. Part C, part 2 says find the value of x for which the graph h of x is a minimum. So in essence, we're trying to find this point here. Now, the one thing about a graph is that we're looking maybe at slopes. Okay, the slope here is negative going down, positive going up, but here at the minimum or maximum, the slope is 0. There is no slope. It's like walking up a steep mountain. You're huffing and puffing. You get to the top. You're walking around. And you go like, this is flat. Your breathing returns, and it's a nice experience. And then you have to scramble back down. Okay, so in a minimum, it's the same thing, just inverted. Okay, so at the minimum, the slope is 0. Now, I wish we had a way of finding the slope. Okay, and luckily we do, thanks to Isaac Newton. We can find the slope by differentiating. Okay, so my first thing here is to find the equation of the function. Now, I've been told in part 1, or I've guessed, whatever, that the roots are x is equal to -2 and x is equal to 8. Now, roots and factors are related concepts. If I bring the -2 across, it ends up being a +2, and that's where I can get one of the factors, x plus 2. The same thing with the 8. If I bring the 8 across the equal, it turns into a -8. That's where I get the second factor. If I multiply those two terms together, I can get the equation describing my situation. Okay. So in this situation, I've written the second bracket out twice, put the first term of the first bracket here, the second term of the first bracket here, and then just gone left, right, and multiplied. Okay. X by x is x squared. X times -8 is -8x. 2 by x is 2x. 2 by -8 plus by minus is minus, 2 eighths is 16. Now I need to combine those two x terms just to make it a little bit simpler to deal with. I owe you €8. I give you 2 back. I only owe you 6. Okay, so that's all we're doing there. And that's the function h of x. Okay, so now that I know the function, I can go ahead and differentiate. If I differentiate a function, it turns it into a different equation. And that different equation describes the change in that system at any point on the system. Again, it took me an awful long time to appreciate how powerful that was. And in college, you could differentiate different parts of something and understand that if the pressure increases in this, what happens to everything else. That's an amazing way to see the world at a very, very precise molecular level. I maybe not necessarily call it that, but understanding what's happening deeper and deeper in a system allows us to have built much, much, much better machines than we could have in the past. Okay, so we differentiate. Now to differentiate here, the x squared, we're multiplying the power by the number in front. There's a 1 there. 2 by 1 is 2. And then we're reducing the power by 1. 2 take away 1 is 1. I didn't write the power here, but by default, there's a power of 1 on everything. Now, the -6x we've learned off, we talked about in a different question. Essentially, there's a 1 here, and the 1 is multiplied by the -6 to give you -6. But when we take 1 away from the power, we get an x term to the power of 0. Anything to the power of 0 is 1. Now, for speed, we learn off that if we're differentiating something with a variable, just a single, powered variable, the variable just drops away. That's what always happens. So just as a shortcut, that's what we do. Now, any number when differentiated turns to 0, because the argument is, let's say this was -16. What's the slope of that? There is no slope. It's horizontal to the x-axis. So it turns to 0 and effectively just goes away. So now we know that a way of describing the slope at every single point. Now we're focused specifically on this point. And we know that at this point, the slope has to be 0. Okay, so this is 0. Okay, so now I realize that, so I can swap it for 0. Then I have a 1 equation with 1 unknown. Okay, so I need to solve this, and I'm going to bring, actually, how do I do it here? I'm going to get rid of this -6 by adding 6 to it. If I do that to one side, I have to do it to the other. Now I've done that to bring it around. A lot of people might just say, I'll bring the -6 across the equal. It turns into the opposite operator and turns into a positive. And I end up with the statement 2x is equal to 6. And that means 2 times some number is 6. The number is 3. Now, I know the x value, and sometimes they might ask me for the coordinates. Okay, and I'd have to put this answer back into my original function, because essentially h of x is y. So if I'm looking for an x and a y, I found the x. If I put it back into the original equation, I find the y. And that's it. But this question didn't ask me to go that step. Okay, so that's question 5. If you want to copy these notes, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.